Let's see in this problem. Here see given 3 by 3 matrix. 3 by 3 matrix is nothing but indirectly, what he asked, a cube minus 3a square minus 5a. For 2 by 2 matrix, a square he asked, a square minus 2a just he asked, a square finding not a big problem. But for 3 by 3 to find a square also it is difficulty and a cube also difficulty. If you find also no problem. For suppose if you find a square and a cube, you and substituting in this matrix, that is a cube minus multiplying a square with 3 multiplying 5a with 5 and substituting in the equation, you will get one matrix. That matrix we didn't have here. Simply that representation is there, that is minus I, 2i, I and null matrix, that is O, not 0. O always denotation of null matrix is good, nothing but O. Always matrices are represented with capital letters only, already we said. Right, how to solve this problem? Each and every problem is going to have some logic. We have to think that in that manner. Here see, this is 3 by 3 matrix, like previously we given one equation. What is that? Indirectly equation for 2 by 2 we given. Now I am giving for a 3 by 3 matrix. That is going to be same for 2 by 2 matrix. A square successive plus minus a plus a square minus of trace of a plus determinant of a into I of order 2 equal to null. Now this is 3 by 3 matrix, that's why the equation is started with a cube. A cube first plus, then after minus, successive plus minus, minus something into, we will say what is going to be answer, something into a square plus something into a minus something into I of order 3 equal to null matrix. Once again I am writing same thing here indirectly. The equation, the degree is started with 3. Why? Because this is 3 by 3 matrix. 3, 2, 1, a power 0 already we said, that is identity matrix I. Same, some values we have to substitute. A value substitute cheste ikkada manaku different, that is answer is going to be equal to null matrix, we have to learn. That is here see, here always second term is going to be trace only and last term is going to be determinant only. In middle you have to write a determinant of 3 matrices addition. How to find this one? What are the 3 matrices? We will see, but we will find the trace here. Now come on, tell me what is trace here. Simply sum of principal diagonal elements, that is 1 plus 1 is going to be 1. Here once again I am writing the matrix here to get easily. Minus 2, 0, 1, 4, 2, 3, 1. Already we said determinant we can find easily, that is determinant of a matrix simply by using our shortcut. You have to say, come on, tell me, determinant is nothing but what? Simply 2 into minus 2 into 0 into 3, 0. Next 1 into 1 into 1 plus 1. Next 1 into 4 into 2 is nothing but 8 minus of. Next is what? Simply 1 into 0 into 1, 0. Next 2 into 1 into minus 2, minus 4. Next 3 into 4 into 1, 12. Here see, what is that? Simply minus 4 plus 12 is nothing but plus 8. Plus 8 minus 8 is going to be what? Cancelled. The determinant is going to be 1. That is determinant of A is going to be 1. Now if you write here determinant, that is going to be 1. Here we required 3 matrices determinant. What is that? Just I am showing here. Here see, come on, just follow me. Right, here see, first matrix determinant, that's why I represented with D. D1 is nothing but determinant of 1 matrix. 1 is nothing but here 1 interlinked. This is 3 by 3 matrix, that's why we got 3 matrices. 3 matrices. What are these matrices? Means simply first matrix is nothing but after eliminating first row, first column, whatever the matrix is there. First row, first column eliminate just such a matrix into the indirectly 1, 4, 3, 1. D1 is nothing but this is D1. The determinant of this matrix is going to be 1 minus 12. 1 minus 12 is nothing but what? D1 is nothing but minus 11. 1 minus 12. Next second matrix, once again same thing, indirectly second row second column eliminate chestoche matrix indirectly by eliminating second row second column, that is D2 is nothing but what? This matrix. This is what? D2. Now come on, matrix 1 minus of minus 4 is nothing but 1 plus 4 is nothing but 5. Next, indirectly what is that? Simply third row third column eliminate chestoche matrix. Third row third column eliminate chestoche matrix, that is going to be D3. Simply what is that? 1 minus 0 is nothing but 1. Simply minus 11 plus 6 is going to be minus 5. What is our equation now? Resultant equation: a cube minus 3a square minus 5a, next minus I of order 3 equal to 0. See, this is our equation, that is a cube, it is a cube minus 3a square minus 5a equal to, if you take minus this side from here, we can write equation that is a cube minus 3a square minus 5a equal to I of order 3. Identity matrix, where it is? It is in third option. Once again I am saying here, listen here, that is our equation is what? Simply this one. Successive plus minus a cube, here coefficient is trace, here coefficient is determinant, here determinant of 3 matrices. Addition 3 matrices D1, D2, D3. D1 is what? After eliminating first row first column, whatever the matrix is there, that is going to be D1. After eliminating second row second column, that matrix is going to be D2. After eliminating third row third column, you will get D3. That is simply, if you add those 3 determinants, then you will get this value. Here trace is nothing but summation of principal diagonal elements. We will write here is CR, same thing we will write by using our equation only, or simply a cube అడిగిండు కింద options exist అని డైరెక్ట్ కూడా find out చేయొచ్చు. Now we are finding here, see, now come on, a cube minus something into a square plus something into a minus something into I of order 3 equal to null matrix. Come on, let's here we will write trace. Trace is going to be what? 1 plus 2 minus 3 is nothing but 0. Next we will write the determinant. Come on, determinant of a is nothing but what? Simply write that is 3 into 5 into minus 1, our shortcut. Simply you have to write here first element last element first. If you write here, you will get 3 into 5 into minus 1 minus 15. Next 1 into 2 into minus 3 minus 6. Next 1 into 6 into minus 2 minus 12 minus half. Next in below, that is minus 3 into 5 into 1 minus 15. Next minus 2 into 2 into 3, 4 3s are 12, that to minus 12. Next here minus 1 into 6 into 1, that is minus 6. Here see, observe, simply here minus 15 plus 15. Why? Because if you multiply with minus, it's going to be plus. Minus 15 plus 15, minus 6 plus 6, minus 12 plus 12. Why? Because minus half you add simply determinant of a equal to 0. You will get here 0. Next 3 matrices determinant, that is what? First D1. D1 is what? After eliminating first row first column, that is D1. D1 is nothing but what? Minus 6. Minus of minus 6 plus 6 is nothing but D1 is 0. Next second row second column eliminate chestoche matrix, so that is minus 3 plus 6, minus 3 plus 6 is nothing but plus 3. Next third row third column eliminate chestoche matrix, so that is 2 minus 5 is nothing but minus 3 plus 3 is going to be 0. Simply here 0, here 0, here 0, that is a cube always is going to be null matrix. If you find a cube by the procedure also, you will get null matrix. That is, if you multiply a 3 times, you will get null matrix. This is the equation for 3 by 3 matrix. You have to remember that is indirectly equal to null matrix we are giving. Okay, 2 by any 2 by 2 matrix also equation is a square minus trace of a into a plus determinant of a into I of order 2 equal to null matrix. For 3 by 3 matrix, a cube minus trace of a into a square plus determinant of 3 matrices addition d1 plus d2 plus d3 into a minus determinant of a into I of order 3 equal to null matrix. So if by substituting these values, if you cross check also, if you find a cube 3a square minus 5a, simply with your minus I also, if you take always you will get null matrix. Okay, this is for 3 by 3, that is for 2 by 2, right? You have to remember these equations. Let's see some properties based upon determinant. Determinant properties we will see, then after based upon properties the problems are going to be what we will see. Okay, we will learn those properties first, then after we will discuss the problem based upon properties. Let's see the properties.